All right, so ladies and gentlemen, let's try to do this. For some reason, my upper pencil's not working. The best I've come up with is my finger, and I know I'm not that good of a drawer with my finger. I'm going to try to do my best here. I might have to redo it, but I did want to try to get this for you. So, a parabola is a curve consisting of all points in the coordinate plane that are the same distance from a given point, the focus, and a given line, the directrix. So the standard equations of a parabola with a vertex at the origin, it has a vertical axis of symmetry. So the axis of symmetry will be your x is equal to 0. And your equation is y is equal to 1 over 4p times x squared. Your focus will be 0 on p, and your directrix will be y is equal to negative p. All right, so let's see how good I can do this. So our axis of symmetry would be here, our x-axis. All right, and that is our x is equal to 0. I will try to do it better if I can figure out why my pencil's not working. But again, our parabola, when our p is greater than 0, will open upwards. Boy, I cannot do this very well. All right, so what it is saying is that we're going to have a focus line there. All right, so that's our focus. Our vertex in this one is 0, 0. And our focus will be at 0 and p. So what they're saying is that somewhere along this, our vertex, I'm going to have something the same length away from this distance here, and this distance here will be the same. And what we'll do is we'll have a directrix, and our directrix will be y is equal to negative p. And notice that it is perpendicular to our axis of symmetry. All right, now I did try to find other ways that I could do. I spent some time doing this, so I do apologize on why this is not working. I have still no idea why. So that's when p is greater than 0. When p is less than 0, remember our parabola will open down. And again, I'll still have a focus here at 0 and p. All right, it doesn't matter that it's negative there. It's still going to be called 0 and p. And now our directrix in this case will still be the same distance. So it'll be up here somewhere. And it doesn't always have to be across the x-axis. But in this one here, again, our directrix will still be y is equal to negative p. All right. As you can see, that's not great, but hey, I'm just showing you. Oops, and see, it doesn't let me move stuff. So I just put an extra one there. I have to move it like this. All right, so let's look at a couple of equations here. Again, maybe tomorrow, if I can get it to look better tomorrow, I most definitely will. Maybe I have to talk to the tech people. I'll definitely have to do this video over because next year I won't say all this stuff. So on this, our focus is right. So equation example 1. Write an equation of a parabola with the focus at 0 and 4, and our directrix is at y is equal to negative 4. So again, if you look at this, this is saying it's a 0 and p. When we have it right here, because they're just kind of showing you don't need both of them. You actually only need one of these because it would still be negative p. So if we look here, our p here would actually be 4, not our negative p, just our p. All right. So knowing that, oh look, I can at least do that. So our p is equal to 4. All right. So knowing that, again, we're just going to use that formula. Now, on the book, and I'll remind you guys tomorrow, the book does say on the first 6 problems to use the distance formula. We don't want you to do that. We just want you to use the formula there. So y is equal to 1 over 4p x squared. So on here, I'm going to say y is equal to 1 over 4p and that's going to be x squared. Well, I just told you our p on this one is equal to 4. So we'll have y is equal to 1 over 16, because 4 times 4 is 16. And then we'll have x squared. I'll definitely be going to the tech people before I show you the homework tomorrow. All right, because I'll still be showing you that. But this is driving me crazy, I can tell already. All right, the second one, now sometimes I'll give you the vertex, I'll give you the focus, I'll give you the directrix and the vertex. As long as we're at 0, 0, ladies and gentlemen, it's pretty straightforward. So on this one here, our vertex is at 0, 0. Our focus is at 0 and 5. So we know on that one there, we're going to say that it's, again, our focus is at 0 and p. All right, so on that one there, our p is equal to 5. So if I just plug it into that formula, it's 1 over 4 times 5 x squared. And when I work that out, I will get that it equals 1 over 20 times x squared. Okay? Man, looks like I just started writing. Well, I'm writing with my finger. I'm not used to it. That's for dang sure. All right, and I keep wanting to move it up, but when I have it this way, I have to use this. So, example 2, it says write, identify the focus, directrix, and axis of symmetry of 12y is equal to negative x squared, then graph the equation. Number 1, you're going to write it in standard form. So to write it in standard form, you're going to get y by itself. When you get y by itself, you are going to divide by 12. All right? So on this one here, we'll get y is equal to 1/12. And that negative will be out in the front there now, x squared. Okay? So now once I know that, we know that we have 4 times what gives us, now it's negative 12, because if you look at it here, there's no negative there anywhere, all right? But we do have a negative there. So I'm going to have to literally attach that negative to that p, so I have 4 times negative 3 equals negative 12. So what I just told you there is that our p is equal to negative 3. So since our p is equal to negative 3, our focus is at 0 and negative 3. And think about it. Our directrix, again, even though it says it's negative, if you think here, we're going to open down, all right? So like when we open down, all right, our P, well, that's not working out very well. There's our P. Our P is less than 0, so negative 3 is less than 0 for our focus. But on our directrix, which would be on the other side, it will be positive, all right? Because if you think about it, well, at least I got that part better. We'll have y is equal to negative times negative 3, because our p is now negative 3, which just equals 3. So our directrix is up here at y is equal to 3. That's our directrix. Remember, our focus, our vertex, is still going to be at 0, 0. Okay? And our focus is at 0 and negative 3. So our focus is going to be here. All right? And then let's go ahead and what I said then on is to choose a table. So if I choose a table, to choose the points. Now I want you to think, I don't want you to do too many of them, just enough to make you draw the parabola. Well, when we have x is 0, we know y is equal to 0. All right? Now here's what I want you to think. I have negative 12 on the bottom. I don't want you to spend a lot of time here on stuff. So when I said I want you to spend a lot of time on stuff, what would be an easy point to choose? Well, if I have 3, if I take 3 squared, that's going to give me 9/12 or negative 9/12. Well, that's going to give me a fraction. Try to use one that's not going to give you a fraction. There, I just did my axis of symmetry for you. And one that will work for you there is 6, because 6 squared is 36, right? So I'm going to tell you I have y is equal to negative 1/12. And I just told you 6 squared is 36. So when x is equal to 6, y is going to equal negative 3. So if I go to 6 there, at the very end, I'm going to go down to negative 3. And again, I will make this better for you. I will make it look a lot better. And then if I did negative 6, again, I would get 3 for that one too. All right, so I'd put one there too. And again, I would just say then you're going to have something that looks like that. I'm trying to get it so that it touches the vertex at 0, 0. Again, it's not the best, but I've never had to use my finger as a pencil before, so that kind of gives you the idea. Remember, this is our focus right here, and that is at 0 and -3. Okay, sorry. Yes, I'm laughing at it because I just don't understand why it's not working. And it is kind of frustrating. All right, but what can I do? All I can do is laugh about it. So on example 3, it says write an equation of the parabola shown. So on this one here, our vertex is at 0, 0 still. So let's write down stuff that we know. So our vertex is at 0, 0. Let's see, our directrix, which they gave us, is y is equal to -p. So if you look at that, our p, since it's negative, is just going to be 2.5. So our p is equal to 2.5. And now we're just going to plug that in. So we'll get y is equal to 1 over 4 times 2.5 x squared. And if you look at it, if you work that out, 4 times 2.5 is 10. So y is equal to 1/10 x squared. All right, so the vertex of a parabola is not always at the origin, as in previous transformations, adding a value to the input or the output of a function translates its graph. So the standard equations of a parabola with the vertex at h and k, the vertical axis of symmetry is somewhere. It's going to be x is equal to h. So again, our axis of symmetry, let's put it somewhere. Remember, it's going to be somewhere on the line, and it's not going to be at 0 anymore. It's going to be at x is equal to h. All right. So somewhere on that, we are going to have a k. So we know that our vertex, again, it's not at the origin. But our vertex is going to be at h and k. And somewhere on this, in between. So the easiest way to think of it is the focus is always going to be inside the parabola. So always think of it that way. So our focus is going to be inside the parabola, on it somewhere. And somewhere along the line, again, from this distance here to this distance here, it's going to be the same. Now, I can't really make it the same, but I did want to show it can even be on the other side of the axis. just as long as this distance here and this distance, which I know mine don't look the same, but again, on this one here, our y is equal to k minus p. And our focus is at h and k plus p. Well, now I'm kind of glad I'm not doing the sideways parabolas for you. All right. So let's see here. And that's for when p is greater than 0. And on this one here, it's going to be when p is less than 0. Okay. We're going to have the same thing somewhere on there. And again, I'm just going to put it over on this other side because it does not matter what side of the y axis is. It doesn't matter, all right? Because it's still going to be the same, all right? So somewhere on this one here, I'm going to put in a parabola. And remember, since it's less than 0, I know it's going to go down. All right. But again, our vertex is still going to be at h and k. All right. So our vertex is still going to be at h and k. I told you our focus is in between. So here, let me use a different color, just because from my great drawing. So our focus is going to be here, and our focus is still at h, because I didn't tell you h didn't have to be negative, and k plus p. In this case, our p would be negative. But again, we're going to have a directrix up here somewhere. That is going to be the same distance. Again, it's not looking the same distance, but you can see that it's there. All right. And our directrix is still going to be y is equal to k minus p. All right. So not bad for, it almost looks like I broke my wrist and I'm writing with my other hand, huh? All right, so let's try one more thing here. Let's try our example here. So write an equation for the parabola shown. So what is our axis of symmetry? So our axis of symmetry goes through the vertex, right? And through the focus. And on this one here, they don't have a directrix. So there's our axis of symmetry. And our axis of symmetry is x is equal to, looks like it's at 2. All right. I just showed you that again, y is equal to 1 over 4 times b, x minus h squared plus k. Now our vertex, again, you can see it right there. It's the green one there. I kind of have it not looking good by my axis of symmetry, right? Which was at x is equal to 2. So on this here, if you look, hopefully you can see it, it's at 2 and it's at 3. All right. So knowing it's at 2 and at 3, okay. Now look at where the focus is. All right. The focus is at 2 and 4. All right. So if we look at it, our 2, and then we have our k plus p. Well, our k was 3, right? So 3 plus what? Sorry, I keep doing that. Again, I have to get used to this. Hopefully it's the only time I have to do it. So k plus what is equal to 4? So somewhere around here, I'll tell you think. Okay. K plus p is equal to 4. You know that your k is 3. So 3 plus what equals 4? Well, you're going to tell me it's 1, right? So if it's 1, look, our p here is equal to 1. All right? So that's our p right there. That's our p right there. 1. Okay? So we know then by our formula, it's going to be y is equal to 1 over 4 times 1. And again, it's x minus 2 squared plus 3. So that was supposed to go with this one right here. So this one right here, because of my great handwriting, we just have to, what's 4 times 1? We are going to say 4 times 1 is 4. So our answer is going to be 1 over 4, okay, x minus 2 squared plus 3. And I will be doing a couple of these problems for you tomorrow. So I do apologize. This doesn't look very nice. I definitely don't like it, but I've spent a couple hours trying to figure out what to do here, and I updated. I did everything I could. So sorry, my writing looks bad. I will redo that and probably redo this video when I have time. So this is it for right now. Like I said, tomorrow I'll show you a lot more stuff, and I'll go through it step by step for you so that you can see what my notes are actually supposed to say. All right? But it gives you a starting point here. Thanks, people.